Then we will demonstrate how simple and straightforward it is to create and execute inspection missions on the Energy Robotics user interface. We will also look at the advanced oil and gas robots integrated into the Energy Robotics platform and watch an exclusive showcase of our upcoming features. But before that, let's have a quick look at what Energy Robotics delivers today. Our mission at Energy Robotics is to relieve humans from dull, dirty and dangerous tasks. In the pursuit of our mission, we offer an AI-driven software platform that enables a mixed fleet of different robots and drones to perform autonomous inspections. With our software, asset owners can manage and scale their global robot fleet using a single user interface. Asset owners in the oil and gas industry are increasingly challenged by the limitations of manual inspections. Firstly, a typical refinery consists of over 100,000 inspections to be performed manually each month. Our research shows that this is the absolute minimum which can be handled by the existing operators in the workforce today, and that many owners want to perform more inspections to optimize plant operations, better empower well-needed predictive maintenance to enhance life of their plants, and save operations of their assets. This puts a huge strain on the operators, especially under harsh weather conditions in the winter or even unbearable temperatures in the plants in the Middle East. Second, the assets to be inspected are often hard to access, making inspection rounds tedious for operators. For example, they usually need to climb 25-meter high tanks to inspect floating rooftops at tank terminals. Potentially explosive ATEX and IECEX areas also increase the complexity and safety concerns for operators. Furthermore, there is a looming demographic crisis in the world. The economic loss because of unstaffed positions is expected to increase to $8.5 trillion by 2030. This crisis is having an impact on the oil and gas industry, with a constantly growing demographic gap in the workforce. A study from McKinsey highlights that frontline departments in oil and gas are feeling the most impact, as more than 40% of maintenance and repair workers are over the age of 55. Especially for the young generation, the oil and gas industry is not attractive anymore, which sends a clear message. In the coming years, the industry needs to do the same amount of work, but with less people. We are looking at a major shift. In some countries, we are looking at the disastrous replacement rates. 2 very experienced technicians retire and just 1 young technician is joining, who then need to work with the technology of the 90s, 50s. Let's summarize. Robots offer a solution to overcome these challenges in asset maintenance and industrial inspection. Manual inspection is tiring and it is binding skilled workers to repetitive tasks. These tasks will be drastically impacted by the labor shortage in the coming years. Robots can take up these tasks at far lower operational costs and free skilled personnel for more valuable adding tasks. Energy Robotics enables asset owners to onboard and manage a diverse fleet of robots and drones through a single interface. Operators can create inspection missions on demand and execute autonomous inspections at the click of a button on the Energy Robotics user interface. The robots execute these missions autonomously with minimal human intervention and deliver AI-driven insights to the operators. We are trusted by industry leaders through our proven global deployments. We have implemented cutting-edge innovations to daily operations, fulfilling our customers' value for safety, reliability, efficiency across industries such as oil, gas, chemical, and power. We have deployed robots across the globe, performing daily inspection missions across 4 continents. Each month, these robots monitor over 50,000 inspection points and saving 1,000 hours of manual labor, keeping people out of hazardous environment and lets the focus on the urgent tasks for supporting the transition in the world of autonomous operations of plants. Let's now have a quick look at how the Energy Robotics software solution delivers value. The Energy Robotics robot brain equipped different robots, platforms and drones to perform fully autonomous inspection missions and collect high-quality data. It is hardware agnostic, optimized for operations in outdoor industrial sites, robust to harsh weather conditions, and outstanding in the industry. The Energy Robotics Cloud Brain provides a 360-degree view of your assets and robots, enabling enterprise-level fleet management, as well as operates on AWS, Azure, and Google Cloud, and integrates seamlessly to digital twins and asset management systems. Advanced AI data processing transforms the raw data collected by the robots into business-critical insights. We have 15 AI analytics skills in production and many more in development. When it comes to hardware platforms, many robots in oil and gas are powered with Energy Robotics Robot Brain. Our robot brain supports more robots in the industry than anyone else. We have integrated 7 robots and drones, enabling asset owners across industry to choose the best fitting platform depending on their use case. We also added the third dimension to asset monitoring through our automated drone inspection solution. Asset owners can easily onboard affordable and off-the-shelf drones used in the industry. Operators can execute automated flights from anywhere with our Beyond Visual Line of Sight or BVLOS approved solution. The drones fly with minimal human intervention and collect high-quality data, which is delivered as AI-driven insights. As an example, here we see the water level AI detection skill, which accurately detects the amount of water, analyzing both thermal and RGB color images. But that's just one of the many skills we have developed, forming a solid AI industrial foundation model. Among many others, these skills include valve on-off detections, fans defect detections, analog gauge reading, and person detection with face blurring. We will have a closer look at the skills during the demo. Before we begin the demo, let's take an exclusive look at the daily operations of our robot fleet in action on one of the world's largest refineries. At this refinery, robots monitor thousands of inspection points multiple times every day with limited human supervision. So operators just click on the inspection points on the Energy Robotics user interface and create new inspection missions. The robots execute autonomous inspection rounds on demand, collecting high-quality data from all selected assets and deliver AI-driven insights to the operators. Some of these include along gauge readings, loop oil level readings, wheel and handle valve detections, to just name a few. You can also onboard a fleet of autonomous robots and execute such marathon inspections daily across your global facilities. Let's see how you can achieve that through a demo at the Energy Robotics user interface, where we create and execute an inspection mission at our Robot Excellence Center. The user interface is completely browser-based and requires no installations. The fleet overview page of the user interface serves as your gateway to asset management. This dashboard offers a comprehensive view of your entire robot fleet, allowing you to easily monitor each robot and drone status. You can also access live video streams from different active robots in your fleet. Clicking on a robot tile will take you to the robot control interface, where you can view, supervise, and manage that robot's individual status, start missions, and access real-time sensor data and camera views. To create a new inspection mission, we first need to record points of interest that we want to monitor. Let's start the recording and drive the robot to the desired point of interest, which is in this case a manimeter. All you need for manual driving robot is simply a gamepad. Once we drive the robot to the appropriate location, we can simply aim the camera at the manometer, capture the image, and save the point of interest. Now the point of interest is saved and can be used as part of an inspection mission. It's that simple. Due to the lack of time, we have already recorded many inspection points which we can now use to create an inspection mission on demand. Let's switch back to the dark mode on the user interface and continue further. Let's click on the mission editor icon and start creating a new mission. We can now select inspection points we created earlier by simply finding them on the list or by selecting them on the 3D map. We add a Go Home task to the end of the list so that the robot returns to its docking station after collecting the data from all selected inspection points. With just a few clicks, we now have a new mission ready to be executed on demand. As we say, just click and inspect. Now let's execute the mission. As we see on the floor camera on the right, the robot undocks from its docking station. The robot now drives autonomously to the first point of interest, which is the manometer we created. As soon as the robot reaches the right position, it aims its camera at the manometer and captures an image. Next, the robot drives to the second point of interest, which is a set of handle valves and a wheel valve. The robot captures an image that includes all the valves. The progress bar at the bottom of the screen shows the status of the mission and the upcoming inspection points in the mission. Next, the robot captures the image of fire extinguishers. While supervising the missions, you can easily switch between the 2D view as a bird's eye perspective and the 3D view for a closer look at the environment. The robot has now reached the final inspection point and captures the image of a switchboard. Having inspected the last point of interest, the robot returns to the docking station and completes the mission. The data collected by the robot for each mission is uploaded to the cloud and user can access it through the user interface. It is also available on our API. Let's open the mission report to view the data collected by the robot. First, we view the gas map, which indicates the gas levels detected by the robots along the length of the mission. Next, we see that the AI skills have processed the images collected by the robot to deliver insights in the form of manometer reading, valve on and off detections, fire extinguisher detections, and switch on and off detections. We can also easily access and compare historical data from each inspection point by simply scrolling through the different timestamps. We've just seen how easy it is to gain business insights by creating and executing inspection missions in a few minutes. But that's not all. We have taken autonomous inspection to the next level by adding game-changing features which delivers value from day one. In complex environments, operators can create robot avoid zones by simply annotating the zones in the 3D view of the site. These zones ensure that the robot plans its route with designated areas and does not enter restricted areas. The user can also annotate and designate other areas for their specific internal purpose. Operators can execute inspection rounds from anywhere and easily switch between different robots in their facility. But our new features are not just limited to robots. We've improved situational awareness for drone flights by integrating satellite views in the user interface. This makes it easier for operators to locate the drone with respect to its surroundings. Not only have we deployed new features, but we also expanded our robot family by integrating advanced robot platforms to give you more options to solve oil and gas use cases most cost efficiently. Tracked and EX certified robots such as the EXR2 from X Robotics and the Inspector from Taurop can be deployed in potentially explosive ATEX IECX Zone 1. Legged robots such as the Animal from Anybotics and Spot from Boss Dynamics give you superior navigational capabilities, especially in multi-floored facilities. We also added automated aerial inspection in multiple facilities with our BVLOS-ready drone solution. We just saw how easy it is to automate inspection runs on demand with the Energy Robotics software solution and the advanced hardware platforms you can choose to onboard at your oil and gas plants or offshore facilities. But what's coming up next is truly groundbreaking. We are working on an evergreen digital twin, which can enable you to accurately visualize sites for pre-planning operations without ever having to set a foot on site. We will be able to streamline maintenance tasks and minimize turnaround times through the constantly updated digital twin created by autonomous robots and drones. Leverage these and other cutting-edge advancements to digitalize your operations. Start automating your inspection rounds. Please contact us today for a hands-on demo. Now I would like to hand it over to my colleague for the Q&A round. Thank you very much.
Today and welcome to the question and answer session. While I answer the first questions that we've already got, please feel free to ask any more questions that you have using the Zoom Q&A functionality. And I'll start out with the first question that we've already received. And the question here was, how does robotic inspection compare with IoT sensors with regards to accuracy and costs? And this is a very good question. IoT sensors are obviously something that is quite helpful in supervising your plant, making sure that everything's running fine, and it's especially good for high frequency measurements. For example, when you need to monitor a certain data point every minute or even every second, then IoT is really the thing to use. But the problem is with IoT that it's quite costly to equip every possible measurement site that you have with an IoT sensor, and especially using high quality sensors there. So on the other hand, with robots, you would use robots for a little bit less frequently monitored data points, like what you need to monitor every shift, every 8 hours or every day. That's perfectly fine to use robots for. And there you can then use much more high quality sensors on these robots because you need them only once on the robot, and you can drive them around the site to do the different measurements. And you can even dynamically change and decide what you want to measure. So the investment in these high quality sensors on the robots pays off a lot more because you can dynamically use them where you actually need them during your normal plant operations. All right, we got a new question here. So we have a question, how do we deal with when the robot does not have Wi-Fi or 5G connectivity? What infrastructure do we need for communication with the robot? It's also a very good point. We usually have most of our robots running on 4G, on public 4G, but we do have the option to run the robots either on Wi-Fi, 4G, 5G, or even private 5G. All of these are possible. And the robots themselves, they operate completely autonomously, so they don't need necessarily to have this internet connection to perform their mission. They can continue their mission even without that connection, but having a constant connection makes things a lot easier for the customer because you have supervision of the robots while they are performing their missions. If there's an area where you know you have a where you have a small zone of no connectivity, this is not a problem at all for the robot. So for example, you can let the robot run with supervision around this area where you have connectivity and allow the robot to perform, for example, a minute or 2 or even longer periods of time their mission without needing connectivity. This is a user setting and can be set up by the customer depending on how they feel about the autonomy of the robot, how much the robot should do on its own without being supervised. This is adaptable. So there's no need for constant connectivity, but it's preferable. So the next question that I got here is the PTZ camera monitoring autonomous? Yes, absolutely. The PTZ camera is part of our sensor solution that we have on many different robots, meaning that the robot is inspecting points very closely with these zoom functionalities. So that means the robot can drive to a certain point in the plant, zoom into something that is maybe 10, 20 meters far away and get a very precise look at this detail that you really want to inspect. And we have multiple functionalities in there to make sure that we have high accuracy even on high zoom levels. So we're not only aiming at a certain angle, but we're actually aiming at a 3D point in space. And then when we have aimed the camera with the zoom, we still perform an additional step, which we call visual servoing. That means we take a picture, we compare this picture to previous reference images, and if we see there's a difference, there's still a misalignment of the camera with the target that we wanted to aim at, we will still make adjustments to be very precise and very repetitive. All right, next questions. Do you use docking stations also as charging stations? Yes, absolutely. The main functionality of our docking stations is to charge the robot. There's additional functionality of them. Some of them offer also shelter from the elements, making sure that the robot is well protected. But the main functionality is to recharge their batteries. And that allows the robots to be fully stationed for months at a time at any plant. And they can completely autonomously perform their missions, recharge, do another mission, recharge. So this is a very common cycle for our customers. All right, I have another question here. Are there any analysis regarding savings and personnel costs for the use of robot inspections? I cannot obviously share all the customer data that we have on this, but I can at least tell you that we do have customers that have already reduced personnel on site due to the availability of these robots and them performing the inspections once per shift with the robot. That allows them to reduce the number of people that need to actually go out onto the site. Usually that means that these people take over other more important jobs, but obviously in general it allows you to reduce the number of human employees that you have on the site on a specific day by performing these very repetitive, dangerous tasks by robots instead of sending humans out into the field in this case. I have another question here. Who's actually sending the robots to our client site? So who's getting them to the client site? Do we have external partners to help you do this, or will someone internally do it? And this is a mixed answer to this. So we work with a lot of hardware partners. Obviously, we are the software brains behind many of these robots, but we are not producing the hardware itself. And that means usually our hardware partners are the ones that will do the actual installation at the site. Even sometimes, depending on the area in the world where this inspection or where the site is, our hardware partners might even have local service partners to help service the robots and get the robots installed and up and running. But what we do as NAD Robotics, we also always send someone from our side, from our customer success team, to the first deployment at the customer to make sure that the customer is well informed about all the things that need to be taken care of, that the processes are being set up, and that they are very much aware of what they need to make it a successful operation with the robots. So we do support during the deployment procedures also physically on site, but usually we have our hardware partners and their service partners do the actual physical delivery of the robot. So there's another question here about what the business model is. Is it a robot as a service formula, or do we sell the package as robot or software, or is it software only? So we offer all of these variations. Most of our customers nowadays use robots as a service, meaning they have a yearly contract with us and the hardware provider, so that they have they don't have fixed cost for buying the robot, but they're actually paying for the robot as well as for the software as a service. So they get both as a yearly fee, and they can do this as long as they need, and they can extend this contract then to keep the robot for the next year. But it's also possible to buy the hardware upfront and then use our software on top as software as a service. This is also a possibility, and it really depends on the cost structure that customers prefer to have, if it should be more an upfront payment or if they prefer to have a yearly payment on this. And also, if they might have already existing robots, it might make a lot of sense to use existing robots and integrate our software on top of that on a software as a service basis. And I see there's another question here about different markets. We are very much focused in this webinar on oil and gas, and this is one of our main markets. But here the question is if there's also options for renewable platforms, onshore substations, or other specific use cases that can be used for this form. And yes, we do have customers that use the robots on substations, for example. This is a very common use case as well. Substations, especially due to the growth of renewable energies, are becoming more and more widespread, so you need more personnel to inspect them, and therefore automating this inspection helps quite a lot. And this is one of our secondary markets. Substations is definitely something that we support. In general, also renewable energy platforms is something that we can inspect. So we're not limited to oil and gas, but it's our main focus market. We do have a lot of other robots that we added to our fleet to support other markets even further. And this is, part is growing and growing in energy robotics as well. So thank you everyone for participating in today's webinar. I'm through with the Q&A part for now, but I have one more thing that I want to give you with. So we have the link in the Zoom chat that you can use if you have any further questions that can be asked asynchronously, or you can also contact us there for a demo. And before we end the webinar, I want everyone to listen to Daniel Böhmer from Shell Energy and Chemicals Park in Rotterdam, where our energy robotics autonomous inspection solution has been constantly adding value already for daily operations for the last 4 years. So these are one of our long-term customers. So thank you everyone, and welcome Daniel. I hear there's an issue with the sound at the moment. We're trying to fix this. Please bear with us for a second. Maybe while we wait for this technical issue to be solved, I can answer one more of the Q&A questions here. There was another question about how do cameras perform in low light environments? And that's a very good question. What we've seen so far, there's many of our robots that are operated at night as well. And obviously in industrial plants, it's never completely dark, but the light availability is a lot lower. And we do have a lot of options. We have a lot of camera options that also perform very well during these low light conditions, especially some of our zoom cameras that we are using for the inspection. They are very much capable of collecting usable data